The Sun is the star at the center of the solar system. It is a massive, hot ball of plasma, inflated and heated by nuclear fusion reactions at its core. Part of this internal energy is emitted from its surface as light, ultraviolet, and infrared radiation, providing most of the energy for life on Earth. The Sun's radius is about 695,000 kilometers, 432,000 miles, or 109 times that of Earth. Its mass is about 330,000 times that of Earth, making up about 99.86% of the total mass of the solar system. Roughly 3/4 of the Sun's mass consists of hydrogen, 73%, the rest is mostly helium, 25%, with much smaller quantities of heavier elements including oxygen, carbon, neon, and iron. The Sun is a G-type main sequence star, G2V, informally called a yellow dwarf, though its light is actually white. It formed approximately 4.6 billion years ago from the gravitational collapse of matter within a region of a large molecular cloud. Most of this matter gathered in the center, whereas the rest flattened into an orbiting disk that became the solar system. The central mass became so hot and dense that it eventually initiated nuclear fusion in its core. It is thought that almost all stars form by this process. Every second, the Sun's core fuses about 600 million tons of hydrogen into helium, and in the process converts 4 million tons of matter into energy. This energy, which can take between 10,000 and 170,000 years to escape the core, is the source of the Sun's light and heat. Far in the future, when hydrogen fusion in the Sun's core diminishes to the point where the Sun is no longer in hydrostatic equilibrium, its core will undergo a marked increase in density and temperature which will push its outer layers to expand, eventually transforming the Sun into a red giant. This process will make the Sun large enough to render Earth uninhabitable approximately 5 billion years from the present. After this, the Sun will shed its outer layers and become a dense type of cooling star, a white dwarf, and no longer produce energy by fusion, but still glow and give off heat from its previous fusion. The enormous effect of the Sun on Earth has been recognized since prehistoric times and was thought of by some cultures as a deity. The synodic rotation of Earth and its orbit around the Sun are the basis of some solar calendars. The predominant calendar in use today is the Gregorian calendar, which is based upon the standard 16th century interpretation of the Sun's observed movement as actual movement. The Sun is a G-type main sequence star that makes up about 99.86% of the mass of the solar system. The Sun has an absolute magnitude of plus 4.83. Mercury is the first planet from the Sun and the smallest planet in the solar system. It is a terrestrial planet with a heavily cratered surface due to the planet having no geological activity and an extremely tenuous atmosphere, called an exosphere. Despite being the smallest planet in the solar system with a mean diameter of 4,880 kilometers, 3,030 miles, 38% of that of Earth, Mercury is dense enough to have roughly the same surface gravity as Mars. Mercury has a dynamic magnetic field with a strength about 1% of that of Earth's and has no natural satellites. According to current theories, Mercury may have a solid silicate crust and mantle overlying a solid outer core, a deeper liquid core layer, and a solid inner core. Having almost no atmosphere to retain heat, Mercury has surface temperatures that change wildly during the day, ranging from 100 K, 173 degrees C, 280 degrees F, at night to 700 K, 427 degrees Celsius, 800 degrees Fahrenheit, during sunlight across the equator regions. At Mercury's poles though, there are large reservoirs of water ices that are never exposed to direct sunlight, which has an estimated mass of about 0.025–0.25% the Antarctic ice sheet. There are many competing hypotheses about Mercury's origins and development, some of which incorporate collision with planetesimal and rock vaporization. Because Mercury is very close to the Sun, the intensity of sunlight on its surface is between 4.59 and 10.61 times the solar constant, amount of the Sun's energy received at 1 astronomical unit, which is roughly the distance between Earth and Venus is the second planet from the Sunday. It is a rocky planet with the densest atmosphere of all the rocky bodies in the solar system, and the only one with a mass and size that is close to that of its orbital neighbor Earth. Orbiting inferiorly, inside of Earth's orbit, it appears in Earth's sky always close to the Sun, as either a morning star or an evening star. While this is also true for Mercury, Venus appears much more prominently, since it is the third brightest object in Earth's sky after the Moon and the Sun, appearing brighter than any other star like classical planet or any fixed star. With such prominence in Earth's sky, Venus has historically been a common and important object for humans, in both their cultures and astronomy. Venus has a weak-induced magnetosphere and an especially thick carbon dioxide atmosphere, which creates, together with its global sulfuric acid cloud cover, an extreme greenhouse effect. Earth is the third planet from the Sun and the only astronomical object known to harbor life. This is enabled by Earth being a water world, the only one in the solar system sustaining liquid surface water. Almost all of Earth's water is contained in its global ocean, covering 70.8% of Earth's surface. The remaining 29.2% of Earth's surface is land, most of which is located in the form of continental land masses within one hemisphere, Earth's land hemisphere. Most of Earth's land is somewhat humid and covered by vegetation, while large sheets of ice at Earth's polar deserts retain more water than Earth's groundwater, lakes, rivers, and atmospheric water combined. Earth's land is part of Earth's crust, consisting of several slowly moving tectonic plates, which interact to produce mountain ranges, volcanoes, and earthquakes. Earth has a liquid outer core that generates a magnetosphere capable of deflecting most of the destructive solar winds and cosmic radiation. Earth has a dynamic atmosphere, which sustains Earth's surface conditions and protects it from most meteoroids and UV light at entry. It has a composition of primarily nitrogen and oxygen. Water vapor is widely present in the atmosphere, forming clouds that cover most of the planet. The water vapor acts as a greenhouse gas and, together with other greenhouse gases in the atmosphere, particularly carbon dioxide, CO2, creates the conditions for both liquid surface water and water vapor to persist via the capturing of energy from the sun's light. This process ends the current average surface temperature of 14.76 degrees Celsius, at which water is liquid under atmospheric pressure. Mars is the fourth planet and the furthest terrestrial planet from the Sun. The reddish color of its surface is due to finely grained iron, oxide dust in the soil, giving it the nickname the Red Planet. Mars's radius is second smallest among the planets in the solar system at 3,389.5 kilometers, 2,106 miles. The Martian dichotomy is visible on the surface. On average, the terrain on Mars's northern hemisphere is flatter and lower than its southern hemisphere. Mars has a thin atmosphere made primarily of carbon dioxide and two irregularly shaped natural satellites, Phobos and Deimos. Geologically, Mars is fairly active, with dust devils sweeping across the landscape and Mars quakes, Martian analog to earthquakes, trembling underneath the ground. The surface of Mars hosts a large shield volcano, Olympus Mons, and one of the largest canyons in the solar system, Valles Marineris. Mars's significant orbital eccentricity and axial tilt cause large seasonal changes to the polar ice cap's coverage and temperature swings between 110 degrees C, 166 degrees F, to 35 degrees Celsius, 95 degrees Fahrenheit, on the surface. A Martian solar day, Sol, is equal to 24.5 hours and a Martian solar year is equal to 1.88 Earth years. Jupiter is the fifth planet from the Sun and the largest in the solar system. It is a gas giant with a mass more than 2.5 times that of all the other planets in the solar system combined, and slightly less than 1/1000th the mass of the Sun. Jupiter orbits the Sun at a distance of 5.200, 778.5 gm, with an orbital period of 11.86 years. Jupiter is the third brightest natural object in the Earth's night sky after the Moon and Venus, and it has been observed since prehistoric times. It was named after Jupiter, the chief deity of ancient Roman religion. Jupiter was the first planet to form, and its inward migration during the primordial solar system impacted much of the formation history of the other planets. Jupiter is primarily composed of hydrogen, 90% by volume, followed by helium, which makes up a quarter of its mass and a tenth of its volume. The ongoing contraction of Jupiter's interior generates more heat than the planet receives from the Sunday. Its internal structure is believed to comprise an outer mantle of liquid metallic hydrogen, and a diffuse inner core of denser material. Because of its rapid rotation rate of 1, Ceres is a minor planet designation. 1 Ceres is a dwarf planet in the asteroid belt between the orbits of Mars and Jupiter. It was the first asteroid discovered, on January 1, 1801, by Giuseppe Piazzi at Palermo Astronomical Observatory in Sicily and announced as a new planet. Ceres was later classified as an asteroid and then a dwarf planet, the only one always inside Neptune's orbit. Ceres's small size means that even at its brightest, it is too dim to be seen by the naked eye, except under extremely dark skies. Its apparent magnitude ranges from 6.7 to 9.3, peaking at opposition, when it is closest to Earth, once every 15 to 16 month synodic period. As a result, its surface features are barely visible even with the most powerful telescopes, and little was known about it until the robotic NASA spacecraft Dawn approached Ceres for its orbital mission in 2015. Dawn found Ceres's surface to be a mixture of water ice and hydrated minerals such as carbonates and clay. Gravity data suggest Ceres to be partially differentiated into a muddy, ice rock, mantle/core and a less dense but stronger crust that is at most 30% ice by volume. Although Ceres likely lacks an internal ocean of liquid water, brines still flow through the outer mantle. Saturn is the sixth planet from the Sun and the second largest in the Solar System, after Jupiter. It is a gas giant with an average radius of about 9.5 times that of Earth. It has only 1/8 the average density of Earth, but is over 95 times more massive. Saturn's interior is thought to be composed of a rocky core, surrounded by a deep layer of metallic hydrogen, an intermediate layer of liquid hydrogen and liquid helium, and finally, a gaseous outer layer. Saturn has a pale yellow hue due to ammonia crystals in its upper atmosphere. An electrical current within the metallic hydrogen layer is thought to give rise to Saturn's planetary magnetic field, which is weaker than Earth's, but which has a magnetic moment 580 times that of Earth due to Saturn's larger size. Saturn's magnetic field strength is around 1/20th of Jupiter's. The outer atmosphere is generally bland and lacking in contrast, although long-lived features can appear. Wind speeds on Saturn can reach 1,800 km per hour, 1,100 miles per hour. The planet has a prominent ring system, which is composed mainly of ice particles, with a smaller amount of rocky debris and dust. At least 146 moons are known to orbit the planet, of which 63 are officially named. This does not include the hundreds of moonlets in its rings. Uranus is the seventh planet from the Sun and is a gaseous cyan ice giant. Most of the planet is made of water, ammonia, and methane in a supercritical phase of matter, which in astronomy is called ice or volatiles. The planet's atmosphere has a complex layered cloud structure and has the lowest minimum temperature of 49 K, 224 degrees C, 371 degree F, out of all solar system's planets. It has a marked axial tilt of 97.8 degrees with a retrograde rotation rate of 17 hours. This means that in an 84 Earth years orbital period around the Sun, its poles get around 42 years of continuous sunlight, followed by 42 years of continuous darkness. Uranus has the third largest diameter and fourth largest mass among the solar system's planets. Based on current models, inside its volatile mantle layer is a rocky core, and surrounding it is a thick hydrogen and helium atmosphere. Trace amounts of hydrocarbons, thought to be produced via hydrolysis, and carbon monoxide along with carbon dioxide, thought to have been originated from comets, have been detected in the upper atmosphere. There are many unexplained climate phenomena in Uranus's atmosphere, such as its peak wind speed of 900 km per hour, 560 miles per hour, variations in its polar cap and its erratic cloud formation. The planet also has very low internal heat compared to other giant planets, which is still unexplained. Like the other giant planets, Uranus has a ring system, orbiting natural satellites and a magnetosphere. Its ring system is extremely dark, with only about 2% of the incoming light reflected, and contains the known 13 inner moons. Further out are the larger 5 major moons of the planet, Miranda, Ariel, Umbriel, Titania, and Oberon, and orbiting at much greater distance from Uranus. Neptune is the 8th planet from the Sun and the farthest IAU-recognized planet in the Solar System. It is the 4th largest planet in the Solar System by diameter, the 3rd most massive planet, and the densest giant planet. It is 17 times the mass of Earth, and slightly more massive than its near-twin Uranus. Neptune is denser and physically smaller than Uranus because its greater mass causes more gravitational compression of its atmosphere. Being composed primarily of gases and liquids, it has no well-defined solid surface. The planet orbits the Sun once every 164.8 years at an average distance of 30.1 astronomical units, 4.5 billion kilometers, 2.8 billion miles. It is named after the Roman god of the sea and has the astronomical symbol, representing Neptune's trident. Neptune is not visible to the unaided eye and is the only planet in the Solar System found by mathematical predictions rather than by empirical observation. Unexpected changes in the orbit of Uranus led Alexis Bouvard to hypothesis that its orbit was subject to gravitational perturbation by an unknown planet. After Pluto, minor planet designation, 134,340 Pluto, is a dwarf planet in the Kuiper belt, a ring of bodies beyond the orbit of Neptune. It is the 9th largest and 10th most massive known object to directly orbit the Sunday. It is the largest known trans-Neptunian object by volume, by a small margin, but is slightly less massive than Eris. Like other Kuiper belt objects, Pluto is made primarily of ice and rock and is much smaller than the inner planets. Pluto has only 1/6 the mass of Earth's moon, and 1/3 its volume. Pluto has a moderately eccentric and inclined orbit, ranging from 30 to 49 astronomical units, 4.5 to 7.3 billion kilometers, 2.8 to 4.6 billion miles, from the Sunday. Light from the Sun takes 5.5 hours to reach Pluto at its orbital distance of 39.50, 5.91 billion km, 3.67 billion mi. Pluto's eccentric orbit periodically brings it closer to the Sun than Neptune, but a stable orbital resonance prevents them from colliding. Pluto has 5 known moons: Charon, the largest, whose diameter is just over half that of Pluto, Styx, Nix, Kerberos, and Hydra. Pluto and Charon are sometimes considered a binary system because the barycenter of their orbits does not lie within either body, and they are tidally locked. The New Horizons mission was the first spacecraft to visit Pluto and its moons, making a flyby on July 14, 2015 and taking detailed measurements and observations. Pluto was discovered in 1930 by Clyde W. Tombaugh, the first object in the Kuiper belt. It was immediately hailed as the 9th planet, but it was always the odd object out 1427 and its planetary status was questioned when it was found to be much smaller than expected. These doubts increased following the discovery of additional objects in the Kuiper belt starting in the 1990s, and particularly the more massive scattered disk object Eris in 2005. In 2006, the International Astronomical Union, IAU, formally redefined the term planet to exclude dwarf planets such as Pluto. Many planetary astronomers, however, continue to consider Pluto and other dwarf planets to be planets. In the 1840s, Urbain Le Verrier used Newtonian mechanics to predict the position of the then undiscovered planet Neptune after analyzing perturbations in the orbit of Uranus. Subsequent observations of Neptune in the late 19th century led astronomers to speculate that Uranus's orbit was being disturbed by another planet besides Neptune. In 1906, Percival Lowell, a wealthy Bostonian who had Ceres is a minor planet designation 1 Ceres. The Moon is Earth's only natural satellite. It orbits around Earth at an average distance of 384,400 kilometers, 238,900 miles, or about 30 times Earth's diameter, having a sidereal period of 27.3 days and a synodic period of 29.5 days. The Moon faces Earth always with its near side by having a rotation period that equals its orbital period, resulting from being tidally locked to Earth. Its gravitational influence is the main driver of Earth's tides and causes Earth's day to lengthen very slowly. Its diameter is 3,474 kilometers, 2,159 miles, which is roughly 1/4 that of Earth or twice the width of Australia, making it by far the largest and most massive satellite in the solar system in relation to its parent planet and the 5th largest solar system satellite overall. The Moon is a satellite planet in geophysical terms and among all planetary mass objects of the solar system larger and more massive than all known solar dwarf planets. The Moon's mass, density, and surface gravity of about 1/6 of Earth's, at 0.1654 grams, are rivaled among solar system satellites only by Jupiter's moon Io. The body of the Moon is differentiated and terrestrial, with no significant atmosphere, hydrosphere, or magnetic field. The most widely accepted origin explanation posits that the Moon formed 4.51 billion years ago, not long after Earth's formation, out of the debris from a giant The Sun is the star at the center of the solar system. It is a massive, hot ball of plasma, inflated and heated by nuclear fusion reactions at its core. Part of this internal energy is emitted from its surface as light, ultraviolet, and infrared radiation, providing most of the energy for life on Earth. The Sun's radius is about 695,000 kilometers, 432,000 miles, or 109 times that of Earth. Its mass is about 330,000 times that of Earth, making up about 99.86% of the total mass of the solar system. Roughly 3/4 of the Sun's mass consists of hydrogen, 73%, the rest is mostly helium, 25%, with much smaller quantities of heavier elements including oxygen, carbon, neon, and iron. The Sun is a G-type main sequence star, G2V, informally called a yellow dwarf, though its light is actually white. It formed approximately 4.6 billion years ago from the gravitational collapse of matter within a region of a large molecular cloud. Most of this matter gathered in the center, whereas the rest flattened into an orbiting disk that became the solar system. The central mass became so hot and dense that it eventually initiated nuclear fusion in its core. It is thought that almost all stars form by this process. Every second, the Sun's core fuses about 600 million tons of hydrogen into helium, and in the process converts 4 million tons of matter into energy. This energy, which can take between 10,000 and 170,000 years to escape the core, is the source of the Sun's light and heat. Far in the future, when hydrogen fusion in the Sun's core diminishes to the point where the Sun is no longer in hydrostatic equilibrium, its core will undergo a marked increase in density and temperature which will push its outer layers to expand, eventually transforming the Sun into a red giant. This process will make the Sun large enough to render Earth uninhabitable approximately 5 billion years from the present. After this, the Sun will shed its outer layers and become a dense type of cooling star, a white dwarf, and no longer produce energy. Mercury is the first planet from the Sun. Venus is the second planet from the Sunday. Earth is the third planet from the Sun. Neptune is the 8th planet from the Sun. Pluto, minor planet designation. Jupiter is the 5th planet from the Sun and the largest in the solar system. It is a gas giant with a mass more than 2.5 times that of all the other planets. Saturn is the 6th planet from the Sun and the second largest in the solar system. Neptune is the 8th planet from the Sun and the farthest IAU-recognized planet in the solar system. It is the 4th largest planet in the solar system by diameter, the 3rd most massive planet, and the densest giant planet. It is 17 times the mass of Earth, and slightly more massive than its near-twin Uranus. Neptune is denser and physically smaller than Uranus because its greater